Hi, this is Suchi and I'm back with another video on this NumPy series. Today, I'm going to discuss about linspace method to create one-dimensional NumPy array. So without further delay, let's look into it. If you remember, in the previous video, we have already discussed about this arrange method, where we can have a NumPy array and within a specific interval, we can generate the NumPy array, where we were just where we were specifying the start point, the stop before point, and the step size. Now, linspace will behave kind of similar. So let's look into it, how it behaves. So if we use arrange, we can generate the array within a particular interval. The same thing we can do with linspace also. But in the arrange method, what we were specifying is the step along with start and stop. Definitely D types also we can specify, data type. But in the linspace method, there is a small difference. Here we don't specify the step size. Step size is automatically calculated. We just tell the function that this is the start point, this is the stop point, and you generate samples within this interval, n number of samples within this interval. So we are just specifying the number of samples we need. We are not specifying the step size. So let us look into the arrange method where it is suitable to use linspace instead of arrange, where we know the number of elements we need but not the step size. We do not know the step size. There we need to use the linspace, that is more efficient there. And there are some sort of instability due to the internal implementation of arrange method, which you can see in this particular example. Let's say we are setting the start point as 0, stop point as 2, and the step size as 0.5. So if it goes like this, if we just simply run this, we do not specify any data type, it will be interpreting the result into float because the step size is in float. But if we specify the data type, it will behave differently. So let me just run the first part without specifying data type and let us see what happens. So here you can see it is generating the array. First element is 0. It is in float. Second element is 0.5. Third element is 1.0. And the fourth element is 1.5. It has created 4 elements and the step size has been taken as 0.5 and start and stop index we specified as 0 and 2. And as you know, the higher the stop point is excluded. We do not include the stop point in case of arrange. And the data type here you can see, I have printed the data type also, which you can see here as float 64. Now, if we specify the D type as integer, what you will expect in this case? So if I convert this particular value into integer, it will become 0. If I convert this one into integer, it will become 0 again. If this is converted to integer, it will become 1. And if this is converted to integer, it will become 1 again. So it should be 0, 0, 1, 1 according to our logic. But if I run this, let us see what happens. So if I run this, you can see this is not 0, 0, 1, 1. Instead, every element is 0 here. So basically, whatever we were expecting, it is behaving differently. It is not behaving in the similar manner. That is because it is adding the step size with the previous element and then converting it to integer. So every time previous element will be 0 here. That is the reason why it is keep staying 0 entirely. So this is how it is not behaving how we are expecting it to behave. So in such scenario, linspace is a better option. So let us look into the linspace. Linspace is almost similar like arrange, but what it does is it takes the start index, it takes the start value, stop value, and the number of elements we need. Here we need 4 elements, so we are just specifying 4. I'm just trying to replicate the same thing with the help of this linspace method. So now I'm not specifying d type. Let me just print it without d type, and you will understand that this is the same thing which we can see above. Here we will specify the d type just for, okay, is not specified. Okay, let me just comment it out. And if I run this cell now, what you are expecting here? The start index is same, which is nothing but 0. The stop is 2. And the step size is not present with us. So what we are passing? We are passing the number of elements what we need. The step size will be automatically calculated. Now if I run this, and here I have put endpoint false. I will discuss this later. This I have put because the linspace method by default considers the last element also as an element. So if I specify 4, it will consider the first element and last, it will include the last element also, the stop point also. So that is the reason why I have set the endpoint to false. So let us just run this first and see what happens. So if I run this, here you can see this is returning the same thing what we were getting from arrange method. 0, 0.5, 1.0, 1.5. So 0 0.0, 0 0.5, 1.0, 1.5. And the data type is float 64. Same thing is happening here. Now, let us do the same thing with data type specified as integer. So in this case, it will give us the correct value, what we were expecting, like 0 converted to integer 0, 0.5 converted to integer 0, 1.0 converted to integer 1, 1.5 converted to integer 1. So it will return us 0011. Let us verify. So if I run this, here you can see this is working perfectly. So this kind of scenario is handled by linspace very efficiently. So in such scenarios, we must use linspace instead of using arrange. And preferably we use integer values whenever we are working with integer values. That time arrange is a very best suit, and when we are working with real values, floating point values, that time linspace is a better use. So now let's look into the parameters of linspace. So as you can see here, linspace is also having the start, stop, and let me just run a help on this linspace so that I can show you what are the other parameters. So if I do a help and I can run this, okay. So here you can see the first parameter is start, second parameter is stop, third parameter is num. Num means the number of elements we want within the start and stop range or interval. And here there is one parameter, and this num is set to 50 by default. If we do not pass any number, then it will be generating 50 samples within that specified interval. Then comes the endpoint. Endpoint is set to true. Endpoint is nothing but it is a flag that indicates whether to include the last or the stop value or not. So if we set this endpoint to false externally, then only it will exclude the last value or the stop value. Otherwise, it will include the stop value. Then RET step, that is return step. This is also a flag. So as I told you, we are just specifying the number of elements we want within that interval, but we are not specifying the return value. we are not specifying the step size. So if we set this RET step, that is return step flag, as true, then it will return the step size, because that is being calculated internally. What will be the step size? And the data type, again, this data type is set to none by default, because that is interpreted from the other parameters. And if it is set to something, then it will be converting the result into that particular data type. And next comes this axis. Axis is by default set to 0. And here you can see what the axis is all about. The axis is the result to store the samples, relevant only if the start or stop indexes are array-like. But by default, it is set to 0. So we do not need to look into this right now, this axis. Just let us focus on these parameters first. So now let us look into some of the examples. So if we want to generate 5, okay, let us just show you how the default values work. So if I just write np.linspace and then I pass the start index, let's say 1, and the end index as 50, or let's say 100. Okay, not 100. Okay, 100 is fine. So what I'm passing is the start and the stop. I'm not passing the number of elements needed. I'm not changing anything. The endpoint flag is set to true by default, and return step size flag is also set to false by default. And whatever other parameters are present, they are set to the default values. So now if I just run this with the start and end index, what will happen? Start and end value, what will happen? So here you can see it is generating an array. So let me have a name of this array. And let us look into the dimension. Dimension is definitely one-dimensional array, because we are talking about one-dimensional NP and ND array, definitely. So what we need to see, what we need to look into the size of the array. Size is 50. So as I told you earlier that it will be by default creating 50 elements. So if I make it, if I specify it to something else, so now you can see the size has become 49. So whatever size I will be specifying here, the function will generate an array of that size. So this will be the number of elements. So here you can see the number of elements have been changed. If I specify 5 here, it will be generating 5 elements only. Here you can see, and the other thing is, here you can see 100 is included here. 100 is the stop point and it is included. It is not excluded. And if we specify the D type to something, let's say int, you can see it has been converted into int. But by default, it is taking up from the, by default, the D type is set to none. Okay. And again, if we just want to exclude the endpoint, that is the 100, we can set the endpoint value as false. Here we go. So here 100 is excluded now. If we want to see the step size, how the step size was calculated, after the step size was calculated, if we want it to be returned, we can just set this return step size, return step, RET step, this flag to true. It will return the step size. So we can print the step size as well. Let me just add a print statement over here. So here you can see this is the array and this is the step size 19.8. Okay. Let me remove this d type, and here you can see this is the array and this is the step size that has been used to generate this array. So likewise, here you can see while we are setting the endpoint to true, which is by default set. So if we do not set it, again it will be same as this one. Okay. So setting endpoint to true and not setting endpoint to anything, by default it will take the true value. So now here you can see from 0 to 2 we want to generate 5 elements. Now let us look into it. So here you can see in the first go where we are setting the endpoint to true, this is including the last element or the end of the interval. This is being included. Now when we are setting the endpoint to false, it is excluding this last element and it is creating a different array. Now return step size. If we return the step size, we can see the step size will also vary while we set the endpoint to true and while we set the endpoint to false. So let us just run this. So here you can see in the first array, the step size is 0.5 while we are setting the endpoint to true. But in the second one, we are setting the endpoint to false and the step size is being 0.4. So that step size is also varying because the number of elements which has to be calculated from within the interval is differing when we are including the last point and when we are excluding the last point. So this is how we can create ND arrays, one-dimensional NumPy array with the help of np.linspace. And again, here you can see we are seeing two variations with data type in same thing. Here you can see while we are setting the endpoint to true, the values which are generated are 0, 0, 1, 1, 2. As you can see here, 0, 0, 1, 1, 2. If we convert each and every element of this array into integer, 0 will be 0, 0.5 will be 0, 1.0 will be 1, 1.5 will be 1, and 2.0 will be 2. Similarly, when we are setting the endpoint to false, this is generating 0, 0, 0, 1, 1. So endpoint flag matters a lot because it can change the result. So that's all about the linspace method. We will discuss two-dimensional array generation with intrinsic functions in our next video. Thank you for watching and keep learning, keep implementing.